Alpine Linux is one of those operating systems that quietly powers a massive part of the modern internet, yet most people outside the DevOps and cloud world barely know it exists. While flashy desktop distributions get attention, Alpine works behind the scenes, running containers, servers, microservices, and critical infrastructure where performance, security, and efficiency matter more than aesthetics. What makes Alpine Linux so special is not just that it is lightweight, but that every design decision behind it is intentional, optimized, and brutally practical. At its core, Alpine Linux is a security-oriented, minimalist Linux distribution built around simplicity, speed, and correctness. Unlike traditional Linux distributions that grow larger over time as features and dependencies pile up, Alpine takes the opposite approach. It strips Linux down to the essentials and rebuilds it in a way that is modern, clean, and highly controlled. This philosophy is the main reason Alpine has become the dominant base image for containers and a favorite for servers that need to do more with less. One of the most important choices Alpine makes is its use of musl libc instead of the more common musl library known as glibc. This single decision has massive consequences.
Musl is designed to be lightweight, fast, and predictable.
It has a smaller code base, fewer legacy features, and a strong focus on standards compliance. This results in binaries that are significantly smaller in size, which is a huge advantage in containerized environments where image size directly affects startup time, network transfer, and storage usage. Musl also reduces complexity, which lowers the attack surface and makes the system easier to audit for security issues. Another foundational component of Alpine Linux is BusyBox replaces dozens of standard Linux utilities with a single compact binary that provides minimalist implementations of common commands like lscp, mv, grep, and many others. While these implementations may not include every advanced option found in new core, they cover the vast majority of real-world use cases. This dramatically reduces disk usage while still maintaining full functionality for scripting, automation, and system administration. In containers and servers where every megabyte matters, this efficiency is invaluable. Alpine also uses OpenRC instead of systemed. As its init system, OpenRC is simpler, faster, and easier to understand. It avoids the complexity and overhead that systemed introduces, making Alpine particularly attractive for environments where predictability and control are critical. This choice aligns perfectly with Alpine's philosophy of minimalism and transparency. Administrators can clearly see what services are running, how they start, and how they interact, without dealing with layers of abstraction. Security is another area where Alpine Linux truly stands out. Alpine is built with security as a default, not an afterthought. It enables stack-smashing protection, position-independent executables, and other hardening features by default across its packages. These protections make common attack techniques such as buffer overflow significantly harder to exploit. Additionally, Alpine uses a read-only root file system approach in many deployments, especially in containers. This means that even if an attacker compromises a running service, persistent modifications to the system are extremely difficult. Alpine's package management system, APK, is fast, simple, and efficient. Package installation and removal are quick. Dependency resolution is clean. And the overall system remains lean, even after installing multiple packages. Unlike traditional distributions that can accumulate unnecessary dependencies over time, Alpine's package ecosystem is tightly curated. Packages are built with minimal dependencies, ensuring that systems remain small, fast, and secure. All of these characteristics make Alpine Linux uniquely suited for containers. In containerized environments like Docker and Kubernetes, startup time, image size, and attack surface are critical metrics. Alpine-based container images are often less than 10 megabytes in size, compared to hundreds of megabytes for traditional distributions. This means faster image pulls, quicker deployments, and more efficient scaling. When hundreds or thousands of containers are deployed across clusters, these savings compound dramatically. Another key reason Alpine dominates containers is predictability. Because Alpine is minimal and consistent, developers know exactly what is included and what is not. There are fewer surprises, fewer background services, and fewer hidden dependencies. This predictability makes debugging easier and reduces the risk of production issues caused by unexpected behavior. Alpine also shines in server environments, particularly where performance and resource efficiency matter. On low memory, virtual machines, cloud instances, and edge devices, Alpine can deliver excellent performance with minimal overhead. Servers running Alpine boot quickly, consume less RAM, and require fewer CPU cycles for background tasks. This efficiency allows more resources to be allocated to actual workloads, whether that is handling web traffic, processing data, or running background jobs. Despite its minimalism, Alpine is not limited in capability. It supports modern kernels, container runtimes, orchestration platforms, databases, web servers, programming languages, and development tools, from Nginx and PostgreSQL to Python, Node, JS Go, and Rust. Alpine provides a rich ecosystem that covers nearly all server-side and cloud-native use cases. The difference is that Alpine delivers these capabilities without unnecessary bloat. One common concern about Alpine Linux is compatibility, especially due to its use of musl instead of glib. Some precompiled binaries and proprietary software expect glibc and may not work out of the box on Alpine. However, in practice, this is becoming less of an issue as more software is built using static linking or compiled specifically for musl. For containerized applications where developers control the build process, Alpine's musl-based environment is rarely a problem and often an advantage. Another misconception is that Alpine is only suitable for advanced users. While it is true that Alpine does not provide a polished desktop experience by default, its documentation is clear, its tooling is straightforward, and its learning curve is manageable for anyone familiar with Linux fundamentals. In fact, many professionals find Alpine easier to reason about because there is less complexity and fewer hidden mechanisms. The rise of cloud-native architectures has further cemented Alpine's dominance. Microservices, serverless platforms, and container orchestration systems all benefit from Alpine's small footprint and fast startup times. When services need to scale up and down rapidly, Alpine-based images enable near-instant container launches. This responsiveness is critical for modern applications that must handle unpredictable traffic patterns. Alpine also plays a crucial role in security-focused deployments. Organizations that prioritize minimal attack surfaces and strong default hardening often choose Alpine for their production environments. Fewer packages mean fewer vulnerabilities, and Alpine's rapid security updates ensure that issues are addressed quickly. This proactive security posture makes Alpine a strong choice for internet-facing services. Another underrated advantage of Alpine Linux is how well it encourages good engineering practices. Because the base system is minimal, developers are forced to explicitly define dependencies and understand what their applications truly need. This results in cleaner builds, smaller artifacts, and more maintainable systems. Over time, this discipline leads to better software and more reliable deployments. Alpine's popularity is also driven by strong community support and corporate backing. Major organizations use Alpine extensively in production, contributing improvements, bug fixes, and security patches. This ecosystem ensures that Alpine remains stable, up-to-date, and aligned with real-world needs, rather than theoretical ideals. In the context of DevOps and platform engineering, Alpine has become almost a default choice. Many official Docker images provide Alpine variants because they offer a perfect balance of functionality and efficiency.
These images allow teams to reduce costs, improve performance, and enhance security without sacrificing capability.
Even outside containers, Alpine excels in specialized use cases such as embedded systems, network appliances, and recovery environments. Its small size and fast boot time make it ideal for devices with limited resources, or systems that need to start reliably under all conditions. Alpine can run comfortably in environments where traditional distributions would struggle. What truly sets Alpine Linux apart is that it is not trying to be everything to everyone. It does not aim to replace desktop distributions or provide flashy user interfaces. Instead, it focuses relentlessly on being the best possible foundation for secure, efficient, and predictable systems. This clarity of purpose is rare in software and is a big reason why Alpine has remained relevant and grown in importance over time. As infrastructure continues to move toward containers, edge computing, and highly distributed systems. The qualities that Alpine offers become even more valuable. Lightweight systems reduce energy consumption, improve scalability, and simplify operations. In a world where efficiency and security are increasingly critical, Alpine's design feels not just relevant, but ahead of its time. In many ways, Alpine Linux represents the future of infrastructure operating systems. It embodies the idea that software should be minimal, secure, and purpose-driven. It proves that you do not need massive code bases and complex frameworks to build powerful, reliable systems. Sometimes, less truly is more. Whether you are running containers in Kubernetes, deploying microservices in the cloud, building secure servers, or optimizing resource usage at scale, Alpine Linux offers a compelling solution. Its dominance is not the result of marketing or hype, but of solid engineering choices that consistently deliver real-world benefits. And that is why Alpine Linux, despite its small size, has become one of the most influential operating systems in modern computing. It quietly runs the infrastructure that powers today's applications, services, and platforms, proving that when it comes to servers and containers, lightweight, secure, and efficient always wins.